I know some of you really like examples and would like me to do more examples. Let's do another example just to do the Thevenin to illustrate the concept in case you didn't get in the previous one, because the previous one we had two sources, kind of getting the superposition and the Thevenin kind of together. So in this example, this additional example, a little bit simpler in the sense that we only have one source, right? We only have voltage source. I would like to find the equivalent circuit, seen the Thevenin equivalent circuit seen by this resistance, 2 ohm resistance. That means I try to find the Thevenin equivalent. I want to find a VT and a ZT, right? So in this case, I'm gonna use the looking back method to find ZT and use open circuit to find V sub T. Okay, so let's first look at the open circuit voltage. So in this case, the open circuit voltage here is the V sub OC. V sub OC, since this open circuit, that means the current is 0 and the voltage across this is 0 volts, right? So what we're trying to find here is basically this is Vx across this 5 ohm resistor. Right? This 5 ohm resistor, in this case we can use the voltage division. Hope so. So in this case, this should be equal V sub x. So I can use voltage division. So this voltage across this one is equal proportion to the impedance of this one divided by some impedance of this two. The total voltage is 12 volts. Again, here if you go clockwise or counterclockwise, Vx and 12 volts source, one of them gonna be the voltage rise, the other one is gonna be voltage drop. So we don't really need any negative sign there. So we just use 5 ohm divided by 5 minus J5. Or plus negative J5 times the total voltage, which is 12. So I get 1 over 1 minus J times 12. So I get the same trick I used before. So I multiply this numerator and denominator by the conjugated denominator. I get 1 plus J times 1 minus J. So I get a negative 2 times 12, so I get a 6 plus J, 6J, right? Because the denominator now becomes 2 and that 12 divided by 2 is 6. So this is the open circuit voltage. So this open circuit voltage is going to be equal VT. So this is my Thevenin equivalent voltage, and for the open circuit using looking back method to find the Thevenin impedance. So this is the looking back, and in this case Z sub T is this impedance plus the parallel of these two, right? So you can get is the parallel of these two. So since these are all in impedance, so in this case the Z sub T is equal J3 plus the parallel of 2. We use the sum over the product over sum, which is 5 times minus J5 divided by negative J5 plus 5. Right. So this is the parentheses. So what I get here is J3, and I get a 5 canceled, so I get a 5. So I get a negative J5 on the numerator plus, and I get a 1 minus J, right? So I use the same trick. I would have J3 plus negative J5 and multiply 1 plus J and 1 minus J, 1 plus J times 1 minus J. So this is 2. So this is 2 here. On the denominator, that's a 2. And on the numerator, what do I get? So I get a, let me, if I can calculate this out. and I got a J3, so 2, I got 2.5, right? So that's a 2.5, and that's a negative 5j times j, that's the positive 5, divided by 2, that's plus 2.5. And also I have negative 5j divided by 2, that's negative 2.5, negative 2.5j. So in that case, I got j3, so I got 2.5 plus 0.5j. Is that correct? I hope so. The numbers. So this should be zt, and this is zt for. If I got the number wrong, I probably won't want to record the video, but you get the idea of this, how we can do this, find the Thevenin impedance by using looking back. The catch here is make sure you don't have any dependent sources in the circuit you're trying to find the equivalent impedance for. Okay, that's the short video for the last example. This will conclude all the parts for the lecture number 4. Okay, see you next time. Remember, no matter what you're doing, keep going, never stop. Okay.